Hello ladies and gentlemen, this is Mr. Miller here again. So here are your Algebra 9 4.2 notes. We are going to look at writing linear equations in point-slope form. This is a different way to write equations when we're looking at them linearly. The other way obviously was what we did in 4.1, which was our slope-intercept form. So it all depends on what information someone has given you and which form you need to represent that in here. So we have a couple warm-ups there. I'm going to let you guys do those warm-ups because we just did that yesterday. So again, practicing, this is your slope-intercept form. So we're going to write an equation in slope-intercept form here for these warm-ups. So the warm-up didn't quite say that, but that is from yesterday's section. So again, just to get you started, remember you need to know y equals mx plus b for both of these. And taking your information, if you have it, and plug it right in, or if you have to do some solving to get your slope, to get your intercept, and then go from there. For today, we have our point slope form, which this is the form for a point slope. It is y minus y1 is going to equal the slope of your x minus your x1. So as you can see, quite a little difference there between our slope-intercept form and our point slope form. We still have a slope, obviously, part, so that is not going to change. But the form for our points versus our intercepts there are going to. So we're going to look at how can we read those, how can we graph those, how can we write lines from there. So start off easy and build up. So first the question says, write an equation in the point slope form of the line that passes through our -1, 4, and has a slope of 2. Now, this is really nice because this is giving us our point. So we have x1, comma, y1. So that is the one point we have, which is very important when we go and substitute this in just a moment. And then we have our slope. Our slope, remember, is our m, so our m is -2. So actually, in this equation here, this is going to be a lot easier to solve in point slope form than what you just did a moment ago in your warm-ups for slope-intercept form. You got to do a little more math up there. Here, I have all the information. I just have to make sure I'm getting my formula down. So, looks like this. We keep the y's and the x's, just like we do in our slope-intercept form. And we're going to subtract. Put in my y1 information. y1 is 4. Equals. My slope comes next. So, that's -2. Times. Keep the x. Formula is minus, and then we put in our x1, which is a -1. And then we would just clean that up. So your point slope form will look like this. Y minus 4 equals -2 x, and it's going to be a +1 when we clean it all up. So there you go. It is as easy as that. So just substituting in. So the big thing is making sure you label this to remind yourself, oh, these go into the ones. We don't want to change the x and y, just like in our slope-intercept form. We do not change the x and y either. So we are finished. So I'm going to let you do the second one here. So write that in point-slope form. You have a point. You have a slope. It's just a matter of substituting those in correctly there. And you can check that answer later. On the back side, so this one we have a little more work to do here. Just a little. It says write an equation in point slope form of the line that passes through 2, 3 and 4, 4. So obviously we have points. So that part we don't have to worry about because we have 2 points we can choose from here, which I'll elaborate here in a moment with that. So we have the points. We need to have the slope. Well, anytime you have 2 points, you can find the slope. So you can start to see how important our slope formula is here. So again, slope formula, divide sign with subtractions. I always take the second one. In this case, they're 4 and 4, so you can't really screw that up. But again, y has to go on the top, the x has to go on the bottom. And then I have my 2 and 3. Again, the 3 is the y, that has to go on top, and the 2 on the bottom. 4 minus 3, 1. 4 minus 2, 2. And we have our slope. Now, all I need to do is pick one of my points. Does not matter which point I want to choose. They're both going to be equations that are correct. And actually, we're going to do both of them. So here, I'm going to go ahead and label this one as x1 and y1. And we'll do the equation for that one. So here, the equation again, because it's on the other side. Remember, it is our y minus our y1 equals our slope, x minus our x1. So I'm just plugging things in. So y minus 3 equals my slope, which is 1/2. And then my x minus my x1 is minus 2. And then we are done. There's one answer. Or if you wanted to take your second points, this is also a valid answer. Just plug those in. Y minus, my y value is 4, equals, the slope is still 1/2. And then x minus 4. There is a valid second answer. So you actually have 2 valid answers for that. That will give us our equation, which we're going to learn how to graph that out right now. So, graph the equation here. So y minus 1 equals a negative times the quantity x minus 2. So again, the formula, ladies and gentlemen, is always going to be negative signs. Okay, just to head up here, formula is always negative signs. So to get the correct point, always think opposite of what that sign is. Or another way you can think of it is, what makes that 0? What makes this 0 inside the parentheses? And that's how we get our coordinates. So again, 2 is my x, and it's just straight up 2. Don't bring the minus with it, because the minus is part of that. Or again, think of it, what makes that 0? That's how I remember for myself. What makes that 0? So if I put a 2 in here, that makes it 0. So 2 is my x. And then over here, what makes this 0? 1. All right? Because again, we're just taking it right from our formula, and the formula has the minus signs in there. So it would not be a minus 1, because if I have a minus 1, that turns this into a positive. All right, so that's the important part, pulling it from there. Then, once I have my point, the slope is just right in front of it, and that's a minus sign. Slope is minus 1, which we're going to be do some graphing here. So I'm going to turn it into a fraction, minus 1 over 1. And to graph it, super easy. You do your coordinates. So where's my coordinate? It is at 2, 1. So 1, 2, and 1. So 2, 1. And then we graph our slope. So again, rise over run. So the rise tells me to go down to the right, and then a positive 1. Down to the right, positive 1. If you want to go the opposite direction, ladies and gentlemen, you can go the opposite direction also. That's up and over 1, up and over 1. And again, what we have been doing is labeling points. So if I was labeling points, it would actually be this one if I had to label 2 because of my slope counting down and over. So I'm at 1, 2, 3, and 0 for my second one there. Just tracing my line for that. So as you can start to see here, we have lots of different points, so we could have lots of different equations for this particular line. I could easily substitute my 3 in there and my 0 in there, and that would be another equation that goes through this. So just as a reference here, so I could go y minus, well, what's my y? It's 0, equals my slope, which was minus x minus my x value, which is 3. So there's another equation. So again, I could have started here at 3, 0, and then my slope is still down 1 over 1. I get my next point. So lots of point slope equations we actually can come up with here. I'm going to let you try that one on your own there. So again, identifying, be very careful. Remember, easiest way is to remember, make the inside 0, make this first part 0. What number makes that 0 to get the correct coordinate? That's the tricky part. Last little bit here, a little story problem here. So we have a table that shows the cost of renting a canoe for different times in hours. Can the situation be modeled by a linear equation? Explain that. So we'll do that first. And if that's possible, write the equation that gives the cost as a function of time in hours. So first things first, this is how I go about looking at it. I'm looking at my differences here with my time and my cost. So what's the difference between 2 and 4? So I'm kind of doing just like the slopes, because if all the slopes are the same, we have a linear function. All right, it's when the slopes change that it does not become linear anymore. So consistently with our slopes. So I have a slope, or difference of 2, difference of 2, difference of 2, difference of 2. And then over here on the right side, we can see we have a difference of 10, difference of 10, difference of 10, and difference of 10. So 10 over 2 is my slope, 10 over 2 is my slope, 10 over 2 is my slope, 10 over 2 is my slope. Oops, can't see my 2's. So this is a linear equation. All right, so we can, so to answer that question, yes, and we have the same slopes. And again, one way to just model that would be, what is 10 over 2? You can take any points and do your slope formula for that. Or like I just did here, it was the difference. So this is what I'm doing in my head just to make sure we're all on the same page. 32 minus 22, those were my y's, and 4 minus 2 were my x's. So that gave me 10 over 2, which was a slope of 5. So I'll clean it up because we do need that information here because we are going to write it as an equation and we do want this simplified there. So again, just took a set of points, found its slope, so 5. So here we want to write a function of time in hours. So for that, we are going to go ahead and do that. All right, like I said here, so making sure we're writing this as a function of our hours. There's a couple different ways you can do this. Considering we're in the point slope section here, I'm going to start it out as a point slope. So if we were looking at a function of our hours, that represents, remember, like our y. And then we subtract that from one of our y values. So that would be y1, and that's going to come out to equal m of our h minus obviously x1. Sorry there for a moment. So plugging things in, you can take any point here. I'm going to take the very first point. So I'm going to take my 222. So there's my x1, there's my y1. I'm going to take that. So Again, you could do this as a slope-intercept form also. We're in the point slope form, so that's why I chose to do it this way, and I'll clean it up afterwards. So our f of h minus our y, which is 22, equals my slope, which was 5, and then my h value here, leave it as h, minus my x1 is 2. Cleaning this up here, so we want to get f of h all by itself, so we're going to add 22 to both sides. So f of h equals 5 times h minus 2 plus 22. And again, I want to clean this up fully here so we don't have to do any extra math when you give someone out the function. So I'm going to go ahead and distribute this. So this becomes 5h minus 10 and plus 22 equals our f of h. And then one last step to clean it all up. So our function of h equals 5h, and that's going to be plus 12. So there's our function. And again, just went from our point slope. Could I have done it the other way using our slope-intercept form? Yes. I just wanted to show you this way as well to clean it up where the function is 5 hours basically plus 12. Thank you, ladies and gentlemen. As always, if you have any questions, please let us know.